Hi, my name is Jacine Rosarda and my modeling project is on cross-extension reflex. This is Ross Tiniflex and he was planning to have a good day until, ouch, he steps on a thumbtack, which causes him to instinctively grab his leg due to the pain that was caused from him stepping on a thumbtack. What just happened? Well, in that exact moment, cross-extension reflex happened. Cross-extension reflex involves the caudolateral reflex arc, thus causing the motor response of the stimulus to also occur on the opposite side of the stimulus. The cross-extensor reflex and the flexor reflex supplement each other and occur simultaneously. This allows the leg that stepped on the thumbtack to pull towards the body through the flexor reflex. This leg is also known as the ipsilateral leg, while the other leg that supports the body weight of Ross through cross-extensor reflex is called the contralateral leg. The reflex contracted of the flexor muscle on one side of the body is always accompanied by the contraction of the extensor muscle. This makes sure that Ross does not fall over and helps him maintain his balance. Both are working as antagonists until the body can formulate a proper response. This is considered to be a polysynaptic reflex because it has more than 2 synapses in the spinal cord. The dorsal root ganglia are a collection of nerves from the dorsal root that then carries a signal to the spinal cord from the pain receptors. Then the pseudosynaptic neuron enters the spinal cord, then the synapse of the motor neurons, then causing the flexor muscles to decrease the angle between the bones. Here. The ventral root consists of the axons from the motor neurons that can be found in the gray matter of the spinal cord, while the interneurons carry impulses to the opposite side in the synapses with the motor neurons. This first cord right here, this purple cord, is the extensor inhibited right here, and this first black cord right here is the flexor stimulated, and this purple cord right here is the flexor inhibited, and this last black cord right here is the extensor stimulated. But now let's take a closer look to the spinal cord. This red line is the pain receptor from the muscle to the spine, and these black neurons are the inhibitory interneurons that are responsible for locally regulating the excitatory neurons. The green neurons right here are the excitatory interneurons that project locally and in long range. During this time, the purple and black cords are leaving the spinal cord that are heading back down towards the leg, towards the extensors and flexors. The green arrows on top represent the motor neurons that help send the signal up to the spine and to your brain to make sure that your body is aware that you just stepped on a thumbtack. Even though it is painful during the moment, it is okay, because cross-extension reflex is an example of a positive feedback loop because it is through the reverberating circuits that use positive feedback to ensure that the movement of the painful stimulus and its reaction of your flexor muscles retracting and your extensor muscles extending lasts long enough to be effective until the painful stimulation of that incident of you stepping on the thumbtack is completely gone. And that concludes cross-extension reflex, which is the end. Yay!